Imagine you write a query that works perfectly, but on only 100 rows. But your company upscales to get 100 million rows. The same query suddenly takes 30 seconds to work. Your application freezes. Your customers get frustrated. And your boss asks just one question: why is the database so slow? That's exactly why we'll be learning about performance optimization today. Yeah, yeah. What is optimization? Performance optimization is the process of improving the speed and efficiency of SQL queries. The goals for performance optimization is fast queries, less CPU usage, less memory usage, and better user experience. Yeah, you may ask, why do queries become slow? Some common answers to this is no indexing, fetching unnecessary data, poor join conditions, too many nested subqueries, large tables, unoptimized where clauses. Yeah, I hope the reasons are clear. Now let's take a look at this inside the SQL. The first thing I'll be doing is dropping the database which I'm gonna use today. We used this in the previous video, so yeah, we need to delete that. Now everything I have written inside a notepad, I'll be copy pasting them so as to save on time and efforts for us both. So I've created the database company DB again, and I'll use it now on. Okay. The first thing which we'll be doing inside the database is in creating a table, of course. The table, it's called employees. We have employee ID, employee name, department, salary, where employee ID is the primary key and employee name is where department is where and salary is a decimal with 0.2 as the highest we can go. Next thing which we'll be doing is inserting some data into this. Let's do this, and if I press enter, done. So we have 8 people in here from different departments. It's all random, so yeah, don't look for your names here. Okay, the first thing which we need to understand is the explain clause. Explain basically shows how my SQL plans to execute this query. Let's put this here. If I press enter, let's see what happens. If I zoom out a little bit, it looks better. So explain is, it would filter the department engineering. It would cost this much time on these many rows. Table would scan on employees and it would take this much time and these many rows. I don't think that's time, but yeah, we get the point. It's the cost, computation cost, I think. Yeah, that's what we need to understand to use the explain clause, I would say. And it's really important when we are dealing with databases with huge data, so that we know how we should optimize it. Yeah, important columns in here is ID, select type, table type, possible keys, rows, and extra. This is just an introduction to this, so let's deep dive into this. So when I do this, I do select all. This is all, by the way. When I select all, what do? I fetch all the columns: the employee ID, employee name, department, and salary. But what if for a specific use case I don't need all the columns? Then what would I do? Then I would only fetch what columns I need. Let's fetch employee names and salary for now. So this cuts off 2 columns entirely, which is employee ID and departments, which saves us on time. Yeah. Now let's do that again, and let's put explain before I do this. Then as you can see, we have only one costing here, computation cost on 8 rows. That's all. But in this case, if we see, we have two specific computation costs required. Fair enough. Yeah, we're saving on something here, which is great. So what happened here is we fetched less data, hence we got faster execution. You see here it's 0.008 and this is 0.006, means that it's higher, lower. But yeah, you get the point. There's more processes running on my PC. It's not supposed to be only for databases, so yeah, that was a bad example to give, but you get the point. Okay, so the next important thing which we need to consider is using indexes wisely. How do we use indexes? Let's try it out. Yeah, I'm using simple query with a select clause, and I'm getting it in these many seconds. But if I create an index, something like this, and if I press, now let's try and execute that index. First thing which we will try is checking index was created correctly. So I use show index. So easy. Yeah, we have, I'll zoom out so it looks clearer. We have an index. It's primary. This one's primary key, it's not an index. This is the IDX name, by name. Yeah. So we have created an index. Now if I fetch the data, everything, all the data, it should be a little bit faster than this. Let's check it out. Yeah. If I paste this here, it should be working perfectly. This took this much time before indexing. It should take much less time this time. It took a bit more time than usual. But again, my CPU is preoccupied with a lot of stuff. There's a Windows update and stuff, a lot of things going on. But you get the point of what I'm trying to do here. Let's continue with the next thing which we have is, can you guess? It is filtering at the right time. How do we filter? SQL. We filter by using statements like where clause. Is this here? As you can see, select employee name from employees where salary is greater than something. Right? If I press enter, you get all the names. Instead of retrieving all rows and filtering later, use a where clause whenever possible, so that it is filtered before it gets processed, so that we save on some computation power. Yeah. Next thing which we need to learn here is limit. Limit is when you need only a few rows. Rows is when this is used. Select all from employees. Limit 5. What does limit 5 mean? It means that it would only give the top 5 names. Let's press enter and see what happens. You get only 5 names out of the 8 names which you have. It's very useful in dashboards, in pagination and testing. Next thing which we need to learn is efficient joins. A bad joiner is joining huge table without condition. A good join, on the other hand, is second. What am I doing? Joining two tables. This one doesn't exist. Yeah, we are joining two tables based on a specific condition where department ID on employee table equal to the department ID on department table. Press enter, it would throw an error because department's table doesn't exist as of now. But you get the point of what I'm trying to say. Or should I make a table and show? Let me just make a table and show. Too much effort for me, because I would have to change the entire structure of this table. I would have to change this from department to department ID, and then I'll have to make another table, use the department's ID in there, and use this join there. But we have done this in one of the previous videos where I'm teaching joins, so just check that out. Yep. The next thing which we need to consider important for optimization is avoiding unnecessary subqueries. Instead of deeply nested subqueries, sometimes join is a cleaner option. I'll demonstrate both of these real quick. So press this, enter. Okay, I'll explain this. Selecting all from employees where department ID and from departments. Yeah, good enough. This is a subquery. We're selecting the department IDs from department, and we are comparing them with the department IDs which supposedly would have been inside this table. But because we don't have both of those arrangements, so let's pass through. It obviously throws an error because departments doesn't exist. This would also throw an error, by the way, but I'm doing it for the sake of explanation. So we are selecting everything from the table E, which is employees, joining with the department's table D, where the department IDs are comparable. Yeah, this would be much faster option than doing this. Imagine the compute used for this specific subquery, then compute used for this specific query. It would be a lot of compute. This would be much simpler option in this case, but you need to decide what you want to do on that specific database on the basis of the compute power which you have, on the basis of how much data you have in those tables. Yeah. Next thing is a bit of theoretical, so I'll love to jump back to the whiteboard. The thing with learning now is called normalization. Have you ever heard of normalization? It was a trend ago. Media. Normalize something third. Normalize something that's unethical or something like that. Mostly some weird stuff people like to do. So normalize data that we avoid having duplicate information. I'll just type it out because I'm too lazy to write today. Avoid go. And what do we do? Instead of employees table storing department names repeatedly, what do? We make another department's table. Use foreign key to reference that specific column in the employees table with the department IDs and department names columns as the department's table. Hope that's clear. I'm sure it's clear because we have learned about this before. Pretty common knowledge, by the way. Some common mistakes people make when they're dealing with optimization is that too many indexes, select all. Yeah, don't need all the columns all the time. Missing where clauses, having duplicate data somewhere, poor schema design, not scheme design. And another thing is fetching unnecessary rows. Yeah, hope that's interesting to you as well. The next thing which we'll be looking into is some real world examples. First example which I love personally, Instagram. Search users quickly. You can simply just start typing and it would fetch the person which we want to add or follow, and it's really quick. Look at it, it happens in microseconds. The next thing is Amazon product search. You start typing and it gives you the perfect product which you are looking for. Next thing is Netflix movie recommendations. Netflix, as you all know, is a great platform for movies and web series shows. So it also uses normalization, not normalization, but query optimization to recommend you movies based on your interests, based on what you have watched before that show. Another good example for this is banking, fast account lookups. Yeah, it all depends on optimized SQL. Yeah, let's sum this video up, but before we do so, I'll start opening my YouTube because I need to promote it as well. God, it's I forgot, almost forgot this. Yeah, today we learned what SQL performance optimization is. We learned how to use explain statement. We learned about select all is not always a good idea. We learned how to choose indexes wisely. We learned how to use limit. We learned how to use efficient joins. We learned how to avoid common mistakes. Yeah. And we also went through how we should write faster SQL queries. Yeah. This is my channel, Decoded. We have 52 subscribers so far, and I'm very grateful for that. Thanks for subscribing if you are watching right. Tell your friends to do so as well. And we have 2 courses out already, Python for Absolute Beginners and Oops in Python. And the video you're watching right now is a part of the 3rd course, which is in the making. SQL Roadmap series, which is a prerequisite for data engineering series, which would be coming after this. It has 13 videos as of now, but when you're seeing this, it would have been 15 videos here, because there's one queued up and one is. Yeah, please do subscribe to the channel and like this video if you like my content. Yeah, then I would like to end this video with one statement that writing SQL that stays fast with millions of records, that's what makes great database developer. Sounds like something Spider-Man would say, but the developer or something. Yeah, that's the point. Yeah, I hope to see you in the next one. Till then, have fun and keep studying.